Cool. So no other announcements. We've got Travis is about to talk about a Pokemon Go clone with React Native. So that's going to be sweet. Also, if anyone wants to take some photos, I tried to replace my iPhone screen myself today. And I went to take some pictures of David, and the camera is like really blurry. Has anyone ever done that, where you like have the little tools?
Oh yeah.
Yeah, it was didn't go, and my Touch ID doesn't work. But so anyway, yeah, take some pictures, you can post them, and then yeah, cool. All right, you ready? Plug it in. I don't know if you have a loud voice or soft voice.
I can use my big boy voice.
Yeah.
It'll be great. Maybe I'll move this a little closer.
Perfect.
All right, so hi everybody. My name is Travis Nuttall. I'm here to talk about building a Pokemon Go clone in React Native. This is a presentation I gave internally at one of my old companies to try and convince everyone that React Native was worth the trouble. Currently, I work at an awesome company called Jolt. We're a pretty small startup in Orem, but we're growing fast, and we're building awesome stuff in React and React Native, hiring every imaginable position from front end to back end, sideways. So if you're interested in writing cool stuff, come talk to me too. So React Native, as you may or may not know, is using React to build native mobile apps. You're probably aware that you can write Android apps in React Native. You can write iOS apps in React Native. Recent development, you can also write Windows apps in React Native. You can write Linux apps on Ubuntu in React Native. But the very most exciting development, if any of you are Westworld fans, if you watch episode 10, you can see right there in the source code, React.create class. So you can build your very own killer psycho robots in React Native. I think that's pretty awesome. But in all seriousness, I really think React Native is awesome. One of my first experiences with React Native was actually working with Russ over here. We built an awesome social networking app, and we made less than $1 million. React Native is just really cool. The learn once, write everywhere philosophy is you learn React. If you know React, then you can write it everywhere. You can write it on the web, build web apps. You can write it on Android, build Android apps. You can write it on Windows PCs and write Windows PC apps. You can reuse this code a lot. And for those pieces that are specific, you can just write specific code for that platform and make it work really well specific for that platform's use case. So it's not, write once, run everywhere, kind of like Java, but learn once, write everywhere. And all these other benefits I found really do pay off, is you get a really great development experience, really high velocity, and you still get high native quality. This kind of, if any of you, has anyone here worked with like Ionic or other HTML5 kind of hybrid frameworks? I've worked with those, and they're great at first, but they very quickly start to slow down. And React Native uses a slightly different architecture than most hybrid apps. It does not run in a web view. It actually runs your JavaScript component code in its own process, its own JavaScript VM, and that JavaScript process speaks to Java and speaks to Objective-C or speaks to C# or whatever underlying platform, and it tells Java, render an Android view for me that matches the UI that I've declared in React. So because you still have this native thread running, you still get all the native performance. And this asynchronous bridge keeps both sides running smoothly. So no, when your JavaScript locks up, which tends to happen in a single-threaded language, it won't lock up the native side. It's still responding to touches and network events and all that good stuff. So this is pretty much very, very high-level architectural overview of how does React Native pull off good performance and good native fidelity. So if there's no questions, are there any questions, high-level questions? I'm not sure. Has anyone here used React Native before on side projects? Awesome. Are there any big burning questions about what React Native is right now? Yes, sir.
Are you shipping anything with it?
Yes. So at Jolt, we build a label printing app where it runs in a little terminal, and you type on it and build labels and hit print, and it'll print them out, and that is a React Native app with a good amount of native code to interface with the printer as well. Great question. So let's build an app. I don't know if you were around last summer, but there's this really cool phenomenon. My childhood dream came true, and Pokemon started to appear in the real world, and it was amazing. I was like, yes! The fad passed pretty quickly. I don't really use it that much anymore, but I thought this was a lot of fun. Does anyone here like Pokemon or Pokemon Go, or know what a Pokemon is, at least? I recently discovered a coworker of mine who has never played Pokemon, and I was sad for him, and I tried to get him to play it a little bit, but I love Pokemon. So I thought this would be a great experiment to see what React Native can do. Can React Native pull off a really cool app like Pokemon Go? I mean, Pokemon Go is a really great kind of app that you couldn't really build as a web app with augmented reality and camera and geolocation. Like maybe someday the web will get there, but for now that's really a native thing. Like you really need native access. And when I started out, I wasn't sure that I could pull this off in React Native. I was a little hesitant. I'm like, this might be pushing the limits a little too far. But surprisingly, I was able to pull it off, and in surprisingly little amount of code. So I kind of distill Pokemon Go into two screens. There's a map screen where you're walking around the world looking for the Pokemon, and then there's the camera screen where you've clicked on the Pokemon and you see it there in the real world and you're trying to throw the Pokeball at it and to catch it. So geolocation and maps in React Native, they exist. React Native gives you maps to work with. It re-implements the browser geolocation API. So if you've ever used the HTML5 navigator.location, you can get it in React Native. And it bridges to the underlying GPS framework, either on iOS or Android. There's quite a few map components that I'll get into later. So this is a screenshot from the docs of how to grab someone's geolocation and watch it. So I have two React lifecycle methods, component did mount and component will unmount. And as soon as my component mounts, I lock on to the global navigator object and geolocation get current position method. That will call my callback with the user's position as they're moving around, and I can set that position into state. I can show errors, I can alert errors if an error happens, and you can pass in some configuration, right? You can have high accuracy, or you can configure how frequently to pull for that location, that kind of thing. And it gives you back a watch ID so that later on, if your map goes off the screen, you can clear that geolocation watcher out so you don't burn your user's battery to death. Like Pokemon Go will very quickly do to any phone that runs it. So I have their latitude and longitude. How do I show a map? How do I follow them around on this map? This probably isn't even in the docs. This is the picture of the docs as of version 40, and I'm pretty sure we're way beyond that. React Native moves really fast. But as soon as I looked at map view, they're like, this is deprecated. It's going to be removed. Don't use this. Use React Native Maps by Airbnb. And I really like that Facebook is willing to lean on the community and to incorporate community solutions. I think that's really awesome. Airbnb is an app that obviously relies a lot on maps, so they were able to just build a better map than Facebook, and Facebook's like, yeah, use theirs. So that's what I did. I used their map view. Here's a screenshot of some code of a map view. This is mostly in case of emergency. Here's the actual code for the map view. The code right now I've updated since I originally created the presentation. So there's a few differences. You'll notice here I'm asking permission to grab the user's location. And I'm watching. I have this location watcher, watch position. And I'm actually not using the built-in API. I started using a library called Expo. Expo makes React Native development a lot easier, and it provides a lot of things that you would normally have to write natively or install native dependencies for, but Expo has provided tons of cool native stuff. So once I get their location, I render a map view. And I render some markers. So let's see if we can get to show up here on our screen an example of what this map view looks like. I think I may have screwed something up. Okay, there we go. So QuickTime, you may not know, allows you to record your phone's screen. So this is my Pokemon trainer right now, here at MX, surrounded by Pokemon. And as we move around, and I actually think I changed it so that even if you don't move around every couple of seconds, half the Pokemon will disappear and 3 new Pokemon will appear. The most difficult part of this was the algorithm to generate random geolocation points around me, and I stole some code from GitHub to do that, and it was awesome. So you'll notice the trainer yourself is in the center, and then your Pokemon spawn kind of randomly around you. So I have here a map view marker. I'm not sure how visible this is. So I put a map view marker inside my map, and the coordinate, this.state.trainer, is the user's current location. So I throw that map view right there, this marker in the middle of the map. Then for the Pokemon, I'm randomly generating latitude and longitude coordinates within a certain radius of you, and I'm just mapping over them and throwing the markers into the map. They have a press handler, so you can touch a Pokemon and transition to the next screen. This whole component is about 150 lines to pull that off. Are there any questions right now about the map? Yes, sir.
So, let's see, what, you said what the browser geolocation?
Yes, so the API looks and feels like the browser, but it's actually using, in this case, the underlying Apple Maps API.
Yeah, that's what it is.
Yep. So when I call watch position, it's asking Objective-C code, use the Apple Maps to get my position. And that map that you're seeing, my phone wigs back up. That map that you're seeing is an Apple Maps SDK. There are tricks you can do. Usually, if you really want to customize your map, Google Maps has a way better SDK, and you can customize everything about the appearance. And you can bundle that in. It just takes a lot more work. But you can bundle in a customized look and feel of your map as well.
So you mentioned the Airbnb's React, their native maps.
Mm-hmm.
So this isn't that one?
This is that one. So Expo includes React or Airbnb's map component in with their SDK. So it's just there and available to you. Yep. And there's some Mewtwo's around. It's pretty tempting. All right, so the second screen, obviously, I want to be able to tap a Pokemon, and I want him to show up in the real world. I want to look at him through the viewport of my lens, that augmented reality, and I want to be able to catch him. React Native doesn't have anything built in to show the camera. There is a camera roll API, so you could hand off to the camera app, have the user take a picture, and then that picture will then come back to your app. So if you wanted to take pictures and work with references to those pictures, you could do that. But because we're an AR app, we really want to control everything about that camera. We want to make it, we want to control all the buttons, control the whole appearance of it. So I had to turn to third-party libraries. I originally downloaded a third-party camera app, this React Native camera. It worked on both platforms. Currently, I'm using the camera app that comes built in with Expo, which they rolled their own. And Expo's comes built in with all kinds of crazy stuff. Like it'll automatically scan QR codes, and it can do some really interesting things. But this is as simple as it is. If you want your whole screen to look like a camera and just look through the viewpoint, you just render a camera element, and it will show up on the screen. Let's take a look over here. The camera is the most complex component in this app because I implemented all of the logic around catching the Pokemon and animating it as all the VR stuff is in there. So I'll try to skip the animation stuff for now. It was a little hacky, but I used the barcode scanner. I just disabled the barcode scanning feature, and I just used that as my camera in Expo. They may have updated this. It's been a couple months since I last worked on this app, so they might have a more generic component, but that's it. I render my camera, and the style makes it cover the whole background of the screen.
Why didn't you use that camera component?
I just wanted to rely on Expo. So one drawback of Expo is they don't give you any access to the native side anymore. They kind of control it. And the benefit is that you can share your app a lot more easily. So anyone, if any of you right now were to download the Expo app on your phone, you could preview my app. It's kind of like a way for, it's a dev tool to share your app. And it's also kind of going on the assumption that you're a JavaScript developer, you don't want to deal with Objective-C, you don't want to deal with Java, you just want to write your JavaScript. So they've gone the extra mile and written tons of native APIs and bridged them over for you so that you don't have to deal with it. So by me making the choice to go to Expo, it made it a lot easier to get my thing running on Android and Apple, but I had to kind of sacrifice the ability to write my own Objective-C and my own native code. Although recently they have added the ability to eject. So if you've built an app on Expo and you hit a wall and you need native code, you can eject out of Expo and you can start writing your own native code. Are there any questions about the camera? I guess we could take a look at it. So it looks like it's all Mewtwo now. So there's Mewtwo. And there he is showing up on my camera. And I think what we're interested in next is how do I keep Mewtwo in the same place no matter where I move my phone? And how do I catch him? So let's see how we pull that off. I guess I gave away the golden goose there. Darn it. All right. Should have saved my punchline for the end. So touch and gesture handling is a huge part. It's really important to native apps. Yell at me if I'm getting towards the end.
You're good.
But what React Native gives you is a pan responder API. So you create a pan responder. You can create as many of them as you want for as many things as you want to be touchable. And what I'm doing is, when my pan responder moves, I am piping that through to an animated event. Animated.event actually returns a function, like an event handler, a callback essentially. And it's expecting an object with a DX field and a value, and a DY field and a value, and it'll map that to my Pokeball animation. My Pokeball will move around as I drag my finger. So it's like, your finger moved up 1 pixel, now the Pokeball is going to move up 1 pixel. Left 1 pixel, Pokeball moved left 1 pixel. So I'm just kind of binding my Pokeball to this pan responder move. Pan responder release is when you lift your finger off. I want the Pokeball to spring back to its original position when I lift my finger off. So I have a little bit of logic. I check to see if the Pokemon is captured. And all I do is I'm watching the location of the Pokemon on the screen and the location of my finger on the screen. And if they're close enough, then they're captured. Otherwise, I use an animated spring, and I spring that Pokeball back to its initial position, which is X and Y of 0. This is my animated image of my Pokemon, and this is my touchable Pokeball. Oh, no, that's my cancel text. Just a second. Here's my Pokeball. So my Pokeball is an animated image, and I translate X. So the Pokeball is in an initial position with normal CSS-looking styles, and then as your finger moves around, I translate the Pokeball X and Y and move it around the screen. I also did a rotation, where as you move from left to right, I will rotate it, either 360 degrees to the left or 360 degrees to the right. Let's take a look at... So this is the code you already saw, where I'm moving the Pokeball around with my finger.
So pan responder is just
Yes.
React Native.
Yep. It's the React Native API that maps to the built-in touch handlers in whatever platform we're working on. Trying to find where I put that rotation. Can't remember. It's in there somewhere. But let's take a look at what the next thing. So the Pokemon that stays in the center, that animation is based on a gyrometer sensor. I'm only tracking the rotation of the phone along the x-axis, so up and down, and the y-axis, left and right. And I'm totally ignoring the z-axis, which is like rotating this way. I'm also not doing accelerometer, so if you move your phone around like this, everything will get screwed up. So you got to hold your phone still and rotate, and then that will work. So that's my restricted use case. And I thought this would be really hard, but what I actually did was I just translated there it is. Track gyrometer. There we go. So I attached, when a component mounts, I start listening for gyroscope updates. And I map the X and the Y that comes back, and X and a Y comes back. And I attach that to my Pokemon's position. And so if my Pokemon moves, let's say I rotate my phone along the x-axis 1 degree. I translate that to 50 pixels, and I move my Pokemon 50 pixels down. Or if my phone rotates this way, I go 50 pixels up. And then for my y-axis, if I rotate in this direction along the y-axis, each degree maps to 50 pixels. And that's all I did. This is all the math right here. I have a slight adjustment based on me just playing around with it, but I'm essentially mapping each degree of rotation to 1 pixel of translation to the left, right, up, and down. And that's where you see the Pokemon staying in the screen. Pretty much every degree of motion just translates into 50 pixels of movement. Now you'll see if I start rotating along the z-axis, that doesn't really work anymore. And if I move too much, oh, that works all right. So that's how I keep that Pokemon in the center. And I believe that my is Pokemon captured there he goes. I just checked to see if they're within 50 pixels. If the Pokeball is within 50 pixels of the Pokemon, then they're captured. We start over. We navigate back. So that is my camera component from a 30,000 foot view. Are there any specific questions about the code specifically right now? All right. I'm not sure how much more time I have, but a common pattern in React Native doesn't replace the native code, it augments the native code. You'll inevitably hit a wall where you'll need to write some native code, and that's okay. Bridging native APIs is really straightforward. React gives you the bridge to talk to each other, and you can totally do that. If we have time, I'll talk a little bit about how animations are performant. And React Native decided to borrow a little technique you may have heard of before called data binding, which is kind of a dirty word in React, but maybe if you're an Angular developer, you're really used to data binding. But the expensive part of the architecture of React Native is not the JavaScript, and it's not the Java or the Objective-C. Those are both actually pretty fast. The thing that's slow is the communication between the two. So talking over this bridge is the most expensive thing you can do. So when you set up an animation in React Native, what you try to do is you try to declare everything about that animation, exactly how it's going to work once, and then React will send that declaration one time over the bridge, and it'll tell Java or tell Objective-C, here's everything you need to deal with this animation, and then it'll just work over the bridge. It'll try to keep everything that it can on the native side. Now obviously not everything's on the native side. My logic, for example, for catching the Pokemon is still on the JavaScript side. So there's still going to be some communication over that bridge. You can't avoid it. So what they try to do to avoid expensive re-renders, instead of storing my animation position in state, I just store it in an animated variable. Like you create an animated.value, like animated.events or value xy. And what React does is it sets up some data binding. So when my animated event updates on the JavaScript side, it will not trigger a re-render in React, because re-rendering in React can be expensive. So these animated events are just data binding over the bridge. They avoid re-rendering in React so that your JavaScript side doesn't slow down. And that's essentially how they're so performant. And there's actually an interesting talk from, I think, the first React rally, where they talk about how animated architecture is performant. Yes, sir?
So, talking about the bridge done client side, or is it done in pilot, like maybe
So the bridge is written in Objective-C or Java, and it's communicating with the JavaScript VM. So it's happening at runtime. While your app is running, JavaScript and Objective-C or JavaScript and Java are talking over this bridge. And this bridge's whole job is to talk to the JavaScript VM, get messages back and forth between JavaScript and native. Yep. Yes? So testing on React Native is really interesting. It's kind of challenging. What a lot of people do is they try to test all their JavaScript stuff separately. So what I do in my test is I essentially mock out the native backend. I mock out all the native components, and I just run my JavaScript, and I make sure that I can simulate a click and assert that a callback was called. I can render my component and assert that a map was rendered, which does a little bit of unit testing right around those JavaScript components. But when you want to actually test your whole app's workflow, you end up having to use other tools. And there's a lot of tools for end-to-end testing on native apps. A really popular one is Appium, which is a little bit like Selenium, where it'll actually fire up your app on a real phone and simulate a finger clicking and moving around. That's kind of akin to writing a Selenium test that fires up your website and drives it against your backend. But most of the tests I write are simple unit tests around this component and make sure that it triggers the callback that I expected, that my function takes in the data that I expect and returns the result that I expect. But it is a little bit of a challenge because running your tests on a phone makes continuous integration a little bit challenging, for sure. Interestingly, if you're doing animations in the browser in React Native, you usually have to use an escape hatch as well. You have to do get DOM node, and you have to manually move DOM nodes around, and you kind of have to break out of that React paradigm for doing animations. Because re-rendering frequently in React can be really expensive. So you use similar techniques in the browser with get DOM node. React Native gives you a similar escape hatch. It'll let you set native props on your elements, and it won't trigger React re-render. It'll send that native prop straight to the native side and force the native side to deal with it. So there's some kind of advanced techniques around animations. And it's all kind of centered around data binding and kind of escaping out of the React paradigm when it doesn't work and make those animations work. That's pretty much all I have at this point. Are there any questions here at the end? Yes?
I was wondering how long it took you to build that.
So I took probably about 3 weekends to throw this together. I was really surprised. I did not have to write a line of native code. It just, React Native gave me everything I needed. This app is open source. It's up on GitHub. Let's see here. This is the original one with vanilla React Native, and then I ported it over to use Exponent to get it to work on Android. So this is up here, github.com, Travis KN. I called it React Native Exponent Pokemon Go. The easiest way to try it out is to go and download Expo on your phone. You can download the Expo app. Let me just show you what that looks like. So Expo has this little exponent symbol. And it's this is pretty much a tool for sharing a work-in-progress app with other people, whether it's a business type of person who wants to see your work in progress, or maybe your fellow developers. And you can browse projects, look at other people's things. And if you have the app on your phone, you open this up on your phone and click this link, then it will open up in Exponent. And you can even scan this QR code from within the app. So they have this scan QR code thing. Boy, this is like crazy inception. But anyway, as soon as you scan the QR code, then it'll open it up. And wow, I think I screwed something up there. But yeah, so anyone can go and play with this. Like I said, it's 2 components, maybe around 500 lines of code. It was a lot of fun to work on. And I hope, when I initially made this presentation, I was trying to convince our internal developers that React Native is not like Ionic. It's actually, you can do really cool, powerful stuff with it and still get all the power of native. And I hope that maybe I've convinced you as well that React Native is not just for toy apps, but it can really build powerful, high-fidelity native quality apps.